All right, so electrochemistry, we're going to talk about how we end up like getting electricity from substances, okay? Not like hydroelectric or things like that, but if we have solutions where we can end up getting and generating electricity, commonly called batteries, okay? So how do batteries work? That's pretty much the discussion of this chapter. Okay, so we're going to study the relationship between chemistry, electricity, and chemical reactions. We're going to talk about spontaneous reactions, and we're going to talk about non-spontaneous. All right. This section here, the spontaneous, non-spontaneous, we actually hold off a couple months on, another month or two on. We'll come back to that part. But we're going to talk primarily about the electricity and the chemical reactions. Voltaic cell then, and like I said, these are more commonly known as batteries. They are an electrochemical cell that uses chemical reactions to produce an electrical current. We have oxidation that's going to occur at the anode, and reduction that occurs at the cathode. Okay, so these are two new terms to you, anode and cathode. But oxidation and reduction, you should be familiar with those now.
What are they?
What?
What are they?
Oxidation and reduction, anode and cathode. Okay, that is the metal where the oxidation is going to occur. And the cathode is going to be where the reduction reaction occurs, the metal that occurs with. Okay. We're going to transfer electrons through an external pathway, and then we will also have something called a salt bridge that we'll get into, but not today, that will return some of those electrons back. The way you remember anode with oxidation and cathode with reduction is a red cat and an ox. Red, reduction, cat, cathode. And then an ox is the other part, so anode, oxidation. So you've probably seen, if you've ever popped the hood of your car, and if you haven't, you need to like spend a moment with your car, okay, or your parents' car, right? Pop the hood. Inside there, you'll see a battery, okay? That battery is used to jump start your car when you get it going, okay? You will notice on there that there is a red terminal on that battery. Have you ever noticed that there's a red and a black? The red is where your reduction reaction is happening. That's why they have it as a red, okay? The oxidation reaction then is going to occur at the black. And if you have jumper cables, you also have a red and a black that you're supposed to match up. That's where they get the red from for your battery. That's where the reduction reaction is occurring. Trivia? Good? All right. So, redox reactions, we're going to start off by balancing what's called half reactions. There's always two reactions that are going on in there. We're going to start off by just kind of baby steps. We're going to do half reactions to start with, and then we're going to combine them and do whole reactions. So you're going to balance half reactions. You balance the oxidation reaction separately. You start by balancing the atoms, then by balancing the oxidation numbers, then the charges, hydrogen and oxygen. Okay? So you're going to determine the oxidation numbers and balance the atoms undergoing oxidation reduction. Balance the oxidation numbers by adding electrons. If you're in an acid solution, you add OH ions. If you're in a basic, you add OH ions. Balance the hydrogen and then check that the oxygen's balanced. Okay? Like I said, we're going to come back to the full reactions. I have those steps written up here on this board so we can refer to them and we don't have to keep flipping back and forth. here is our first reaction. We're going to take these as half reactions today. And then I'll show you tomorrow how we're going to bring them together and make full reactions. Okay. So if I break this down, I'm going to look at the two halves of the reaction. This is the one half that I'm going to start with, which is MnO4. And was there a typo on your sheet for this one? No, that one was okay. It's the next one that's the problem. So that is going to yield Mn2+. Okay. This guy, this is in an acid solution. Is this the same one you have on your sheet? I'm good? Okay. And it said that this was in an acid solution. Okay. My MNs are already balanced. I have one over here and I have one over here. So I can skip step 1 on my sheet, on my checkoff. I'm going to go and I'm going to balance my oxygens. So over here I have 4 oxygens. Over here I don't have any. So I'm going to have to add water. To get 4 oxygens, how many waters do I need to add? 4. Okay, so now my oxygens are balanced. Now I'm going to attack my hydrogens. Over here, how many hydrogens do I have? 8. So over here, I'm going to add H pluses to get to 8 hydrogens. So 8 H plus MnO4 minus yields Mn2 plus 4H2O.
Does hydrogen being alcohol have anything to do with it, or it's just the H plus?
It's an H plus. Okay, so it's an ion. We're not going to Brinkelhoff here because it's in the form of an ion. It's in an acid solution, so it's going to be ions. All right, so once I have my H plus here, I need to balance my charges. Over here, I have 8 positives plus 1 negative. So over here, my overall charge is what? Plus 7. Everybody buy that? Everybody see that that would be a plus 7 on this side? Okay. I'm just going to erase this and write a plus 7 now that we've established that. Over here, what's my charge? 2 plus. Everybody buy that? Yeah, this is a molecule, so there is no charge for this guy. All right, I need to get these charges equal, and I'm going to do that by balancing using electrons. So which side do I need to add electrons to get it equalized? This side? Yes. Okay. So if I add, how many electrons to get to a plus 2? 5. Okay, so I need to add 5 electrons, and that's going to get me up to a plus 2. So 8H plus MnO4 minus plus 5 electrons is going to yield Mn2 plus 4H2O. Okay, so that's that half reaction. Okay, questions on that guy? He's balanced now. For that half reaction, yeah. We're eventually going to get to the point where we're going to add these together. It's much easier when you're in an acid solution than when you're in a base solution.
We need Alexia and Mitch. You're just gonna wander with them? That's your choice?
Yep.
Smart.
Yeah.
All right. So question. I wrote that down right, I believe. Okay. This is the other half reaction from. Don't you have MN right here? Okay. We're gonna do the other half reaction. So I gave you another box there, like blank box, to be able to kind of go into. Okay. Random things from social studies. Okay, so here I do have to balance out my atoms because I've got stuff that's out of balance other than oxygen or hydrogen. See that? Okay, so I'm going to go C2O4, 2 minus, yields, and I'm going to put a 2 here to get this to balance for my carbons. Right? We're still in an acid solution. I'm going to balance my oxygens next. Over here I've got 4, over here I've got 4. So I'm balanced with my oxygens. I think that's... Yeah, I think that's all we had to... We just need to balance our charge now. Okay? So our oxygen's balanced. We had no hydrogens because we didn't need to balance our oxygens. So now all we have to do is balance our charge. So over here, I've got 2 minus. What do I have to do over here to get this guy to 2 minus? Right, I need to add 2 electrons, and that's going to get me to my 2 minus. Okay, so that one was a super easy one. Okay, questions on that one? That was easy. I like easy ones, don't we? Okay, so here's another one. Again, this is in an acidic solution. There was a typo on your sheet. There should be a 2 minus here for this guy. So add that in, or else this doesn't work out so hot. Okay. So we're going to break these down into 2 half reactions. So the Cl's will go together, and then the chromiums will go together. So Cl, I've got Cl minus, yields Cl2. First step, I'm going to balance my things that aren't oxygen or hydrogen. So I'm going to put a 2 there. I don't have oxygen or hydrogen to balance, so I don't need to mess with the next few steps, but I do need to balance my charge. Over here, I've got how many negatives? 2. So how many electrons do I need here? Easy?
No.
That one's not easy? Okay, good. All right, everybody good with that one?
So if it's not labeled with the charge, it's neutral.
Yeah.
And then the coefficients correspond to electrons, but the subscripts don't. Or did the subscript? If there was a subscript, would that also? You know what I'm saying?
Here.
Yeah.
Um.
Would that mean there's 2?
Yeah. Yeah, you would have 2 charges then as well. But like here, let's do
Yeah.
this one. Okay, let's do that. Okay? So we'll go through that one. I think that might answer your question. Okay, so let's do this guy up here. We have CR207. And that has the -2 charge that I didn't type in there, which I should have. Sorry. CR3+. All right. So first step, we balance everything but oxygen and hydrogen. So I've got 2 chromiums there. I need 2 chromiums here. Okay. Next step, I'm going to balance my oxygens by adding water on the opposite side. So here I have 7 oxygens. I need to get 7 oxygens over here. So how many waters am I going to add? 7. Okay. So now I've got my oxygens out. I need to balance my hydrogens. So I need to add over here hydrogen ions. How many do I need to add? 14. Okay. So I have balanced my oxygens. I balanced my hydrogens. Now I'm going to balance my charge. All right. So over here, I have 14 pluses. I have a 2 minus, so my overall charge on this side is how much? Plus 12. Okay. Over here, I have 2 and 3 plus, so that's going to be 3 times 2 is 6. So I have 6 pluses over here. So which side do I need to add my electrons to? The one closest to me or furthest away? Closest. How many do I need to add? 6 electrons. So my overall answer for this is 14H plus CR207 with a 2 minus charge plus 6 electrons yields 2 CR3 plus 7 waters. What you think? Better? Did that answer the I don't think that answered your subscript question.
Well, when we were trying to find the charges to balance it, you just took 2 minus. It wasn't like.
Right.
So I mean that's.
Okay. So you're good. All right. Okay. So questions on anything that's up here so far before we move on? All right. So basic solutions, we have to add a few more steps in. And they're not quite as fun. So for this guy, we're going to break it out. We've got our CN, our cyanide ion. It's going to give us CnO minus. There was a typo on this one as well. This 4 should be down here instead of a superscript. So, did you make that fix on here?
Is it still a -1 charge?
Mm-hmm. Yeah, it's just I superscripted that when I should have subscripted the 4. You know how that is, where you have to, in Office, you have to like highlight it and, yeah. Sorry. All right, so everything's balanced with our oxygens and with our non-oxygen, non-hydrogen. So now we're going to balance our oxygens. I'm going to add water over here. How many waters do I need to add? Just one. Yep. So I'm going to add a water over here. That gets my oxygens fine. Okay. But that gives me hydrogens now. So on this side, I need to put down how many hydrogen ions. How many hydrogen ions am I going to need over there? 2. All right. So that's the way we've been doing it. Yes?
If it's a basic solution, do we add OH or no?
We're going to get there.
Okay.
We're getting there. Okay. So I'm balanced using the hydrogens, and then I'm going to go to these things. Okay. So I balanced my hydrogens. Now I'm doing my OH business. Since this is in a basic solution, remember basic solutions have a predominant value of OH ions. They have more OH ions than they have H plus ions. So that's why we have to go through an extra step on this, or extra steps. So when I added the OHs or the hydrogens here, I have to add an equal amount to both sides of the OH ion. So I have to add 2 OH minus over here. Okay. So I've added an extra OH for each H I've formed. Okay. Now I'm going to combine anywhere that I have H's and OH's. I'm going to combine those to form water. I combined these two to make that. Then I cancel out the waters on each side. So over here I have 1, over here I have 2. So this guy here, I can't change my color today. This guy here is going to go away, and that 2 will then go away. They cancel, I'm canceling them. Does that make sense, what I just did? All right, then I need to balance my charge. Over here, I have 2 negatives, 3 negatives. Over here, I have 1 negative. So I need to do what? 2 that side. Okay. So the overall the overall half reaction, because we haven't brought these together yet with the previous one. That's what it looks like. Okay, that makes sense with the basic one. Do another one. Do the other half of the reaction here. Okay. So my manganese is balanced on both sides. My oxygen, however, is not. So I need to add in what on this side? How many? 2. Okay, I add in 2 H2Os there. Then I need to balance my hydrogens out on this side, so I've got to have H plus over here. How many am I going to need? 4. Okay. If I added 4 H pluses over here, that means that I'm going to have to add what next? 4 OHs to both sides. I'm going to then combine these together to make what? How many? 4. This water will then cancel, and this one will go down to 2. Then I can start balancing my charges. Over here I have 1 negative. Over here I have 4 negatives. So what do I need to add to this side? 3 electrons. All right, questions on that? Tomorrow then, we are going to combine these into one equation. So right now we've done the half reactions, the 2 halves. We're going to take these kind of end statements here and combine them together to make one overall reaction. But I don't want to throw too much at you at one time, okay? Quiz tomorrow is going to be on redox, okay? The stuff that you've learned up to today. So can you identify oxidation numbers? Can you identify which element is the reduction element and which one is getting oxidized? All right, that's primarily what your quiz is on tomorrow. Not just primarily, that is what your quiz is on tomorrow. Okay, I'm not going to have any of this business on it yet because you haven't had enough time to practice it. I don't feel anyway. Okay, I also don't feel that the quiz should take you that long either. So we're going to go into, hopefully we'll be able to get to these where we do the combination. Because it's not that much more to combine these. You're just canceling some stuff out. So, okay?